Okay, for this question we're going to look at half-life from a graph. Okay, so what you'll see a graph is usually a curve. You may now just get the points and you may have to draw a line of best fit through them. So the first thing is to remember that it always hits the y-axis. There's an intercept. Okay, most people tend to forget that, so just make sure that if you have to draw your line that it does go back to the point in the y-axis. Okay, so the first one here is what is the activity after 5 days? So what you have to do is we've got our time axis in the bottom and we have our activity on the y-axis. So after 5 days, what you'll do is you just go to 5 days, draw a line up, see where it hits your graph, and then draw a line across. Okay, now then you have to sort of work out your scaling here. Now I've been very lucky that each little square represents 1 because there's 10 squares in between 10 and 20. So that's 3 squares up, so my activity then must be 13. Okay, next one, what is the half-life of this isotope? So, what is half-life? Half-life is the time taken for the count rate or to fall to half its initial value. So count rate is exactly the same as number of radioactive particles, activity. Okay, they're all sort of the same thing for GCSE. So I obviously have an initial value. My initial value is this point here, okay, where it hits the y-axis, so that's 80. So if I wanted to fall by half, so I'm going to look at dividing the answer by 2. So 80 divided by 2 is equal to 40. So that's my initial. Half of that is 40, so I'm going to go to 40 on my y-axis. Then I'm going to draw a line, okay, till it hits, line across till it hits my graph, and then read down. Okay, so my half-life should be 2 days. Now obviously if we're going to take another half-life, divide this by 2, so it's 20. If the half-life is 2 days, so 2 plus 2 is 4, so we should hope when we go and read the graph that for activity 20 to 4 days have passed. Yeah, okay, so you know definitely your half-life is 2. Now the last one, use your graph to find background radiation. Okay, what is background radiation? Background radiation is the amount of radiation that remains once all radioactive materials have been removed. So that's if you had like an alpha, beta or gamma source in front of your GM tube. Once you remove them, there still should be some background radiation. So that is where my graph sort of levels off. Okay, so here, this is my background radiation. So if I just look at that, because it's remaining constant, and my value for that is 5. Okay, so that is my 5. Okay, the other half-life questions they could ask you would be on a calculation. I'll show you how to do that next.